This is Chem 2204, and we're talking about experiment number 8 today, which is the alkene cis-trans isomerization. So what we're doing today is we're taking maleic acid, which is a cis isomer, and we're heating it up or refluxing it, and that's going to provide us with the activation energy in order to transform that into its trans geometric isomer, which is the fumaric acid. Today we're taking a round bottom flask, the 100 ml round bottom flask, and we're going to weigh out 5 grams of the maleic acid, and we're going to add 5 ml of warm water. And I've just been warming this in my hand. You can use the same method, or you could pour some hot tap water over top. Just make sure you're using the distilled water for adding it to the reaction. So we're going to add that in here. And we just want it to be warm so that it will help us dissolve the maleic acid, because it is hard to do at room temperature. If you don't get all of your maleic acid to dissolve before you heat, once you start to heat it, it will dissolve into the water, so it's okay if you don't get all of it dissolved. Then we're going to add our 10 ml of HCl. We're just going to add that in there. This is just going to provide us with an acidic environment. And we'll give that a swirl. And what we can also do to help this dissolve is actually use the hot plate before it starts to boil. You don't need the condenser on, so we can just roll that around and swirl it in the heat of the hot plate just to get it going. So I have my hot plate on. And again, we have it raised up on a ring clamp, and that's in case the boiling today during the reflux starts to get out of hand, or if you get any bumping, then you can drop the heat right away and you won't have to worry about getting product up into your condenser. And I also have set the condenser up. It's ready to go, and once again we have water running in through the bottom and out through the top. And it's just a slow trickle of water. So this is getting pretty close to being dissolved, so I'm just going to set this right up, bring it down so it's sitting in the nest. And then we'll position our condenser right in the top. So right now, I have the hot plate sitting at about a 10 on the variac. Remember that you're plugged into the variac, not the regular outlets again today. And so we're just going to heat this, except that I forgot a very important part, and we want to make sure that you don't forget this either. Before we start refluxing, we need to add 3 or 4 boiling chips, and that's these black little solid pieces here. So I'm just going to raise this up. So that it's out of the way, so it's fine there. And with a spatula, we're just going to grab, not sure if you'll be able to see this, but I have 4 tiny little boiling chips. We're just going to add that in the top here so that they're sitting in the bottom. And that's going to help prevent any bumping that might occur during the boiling. So make sure that you have your boiling chips in there before you put your condenser on. And it'll just take a while to get up to temperature here. And for this reaction today, it is very important that at least one of the partners is keeping an eye on the flask at all times, because bumping does happen a lot with this experiment. So again, just to rephrase, if you do get lots of splashing inside your flask or it's bumping, just remove the heat. So drop your ring clamp and remove the heating mantle to cool it down a little bit. If you end up getting any compound splashing into the condenser, you can just take a little bit of warm water and a pipette and just rinse down the walls of the condenser. And that will bring any of that product that came up and got stuck on the condenser, it will just bring it back down into your flask. Once you have that all set up and the boiling is going, you just let it go for half an hour, making sure you keep an eye on it the whole time, and then we'll be cooling it down and letting it solidify. So now that we've been refluxing for half an hour, we can turn off the heating mantle and drop it out, and we're going to cool our flask down to room temperature. So while this is happening, just make sure we leave the condenser on for the time being. So I'm just going to take out my ring clamp here, or you can swivel it to the side and drop my heat and actually put it right away. And so this is going to cool down to room temperature. And next part, we're going to be putting it in an ice bath, and that's going to allow all the compound to solidify out. When you are ready to put it over into the ice bath, you know that if you can actually hold it completely in your hand and not feel like it's going to burn your skin. So you want it to cool down to room temperature, and once you can hold that in the palm of your hand, then we can transfer it over into the ice bath and leave that for about 3 minutes. So we've heated our reaction for half an hour and then cooled it down to room temperature, and I've now put it into an ice bath. So it's sitting there. While that crystallizes out, I'm going to show you how to set up for your filtration. So this is the suction filtration, as you've done in the first semester, but I'm just going to take you through it one more time. So here, just a reminder, we have 2 different hoses. You'll be able to find both of these in your drawers, but the difference between these is the thin one is used for your condenser and only your condenser, whereas the thick one is actually able to withstand the vacuum pressure that we're going to be using today. So you want to make sure you're using the big fat hose for the flask here. So what we're going to do, I have the flask clamped here. Make sure it's clamped, because when you turn the vacuum on, there's often a little jolt, and a lot of the time the flask will fall right over and break, and they are fairly expensive. So you want to make sure that it's clamped, and then we're going to attach the hose here on the side arm and just make sure that's on fairly well. And then we're going to take the other end and we're putting it right onto our vacuum system here. And again, a reminder, our vacuums are set up for 2 different groups to be able to use it at the same time. So if you're using it with just one person, you want to make sure that the other side is off so that it's not going to suck air in here and then change your vacuum. So you want to make sure the second one is closed. And this one, we're going to leave closed right now because we're going to first turn on the vacuum, which will allow vacuum to come right in here. So we do that by with the orange valve. You can see maybe if we trace this up to the vacuum controller here, and then there's this tube. The tube comes out and it actually goes around to this orange pipe here, and this is where the vacuum is going to come from. So we're going to turn the vacuum on by turning the orange knob right here, and I'm just going to shut that off so you can hear me. There's 2 different orange taps, and just in case you're not sure which one to do, if you accidentally put the wrong one on, air is going to flow out of this orange tap, so you'll be able to feel a flow. And it's okay if that turns on, just make sure you turn it right back off and use the other valve for the vacuum. So we're going to turn that on, and we're going to open it right up. You'll notice that as you turn the valve, you can see the needle on the gauge moves up. So the further it goes this way, the higher vacuum you have. So now that our compound has crystallized out in the ice bath here, we're going to take that and transfer that into our filtration system. Now, it's going to be really difficult to transfer all of the compound out of the round bottom flask into the top of the Buchner funnel. So what you want to do is you want to make sure that the flask you're filtering into is completely clean, because what we're going to do is we're going to collect this, the solution that passes through into the bottom of the Erlenmeyer flask here. We're going to transfer that back into the round bottom flask and use that to rinse the sides off, and that will help us increase our yield. So here, I'm going to do my best to transfer as much as I can. The other point to make is you always make sure that your filter paper, which I have in here, and I'll just show you that. So we have our little filter paper in the top, and I'm just going to take a little bit of water and wet that down. And it really doesn't take too much. You just want to make sure that the paper is flat to the bottom of the filter. And so now I'm going to turn the suction on, and I'm going to transfer over as much of the compound as I can. And I'm just going to explain as much as I can to you right now because the vacuum makes a lot of noise. So once we turn the valve and turn the vacuum on, then you want to make sure that you open this valve, and that's going to allow the vacuum to come into the rest of the flask. So now, when you saw that I was stopping the vacuum, you'll notice that I closed this first. And that's to ensure when the vacuum's turned off, any solution that's in the bottom doesn't get sucked up the hose. It's very important to break the connection there, because if you'll notice, things often get sucked up into the vacuum controller, and then we end up getting a lot of spillage in the back. So make sure that we keep this clean. So now what we want to do is we're going to take our solid off here and take the hose, and we're going to be taking this solution that's in the flask, if I can get it out there. Actually, I'm just going to grab a little holder for this. So now we have our filtrate here, and we're just going to transfer that back into the round bottom flask. There we go. And we're going to use that to rinse out the rest of that compound. So we'll set this back up here. Put our funnel back on top. Now we'll be able to get more of the compound that was stuck to the sides of the glass. So again, I'm going to turn the suction on. And just to show you one more time, we're going to close and then break the vacuum here and turn it off. You'll notice that we still do have some solid on the sides of the flask, so you can repeat that procedure as many times as you want to get that full transfer. From here, all you have left to do is you're going to take some of this crude sample and you're going to set it aside, because you need to take a melting point before next lab of the crude sample, and then you're going to be doing a recrystallization just as we did in the experiment 1 with the salicylic acid, and you're going to be recrystallizing from HCl. And so you're going to want to take a melting point of the crude sample and the purified sample, as well as an IR of the pure sample for next lab.